Everybody, can you see my screen? Okay. Yes. So let's take the first doubt, that is exercise 7.3 question number 18. Let me take that. So at first we are going to take the doubt, that is exercise 7.3, and here we are having question number 18. Let me write the question over here. So the question is, find the integral of the following function. We have to find the integral of the given function, and the function is cos 2x plus 2 sin square x divided by cos square x. This is the given function, right? And we have to take the integration of that. We have to find the integration of this given function. So here what can be done? First, we need to simplify the given function by applying the trigonometric formula. So which trigonometric formula can be applied over here so that we can reduce the given function and it will be integrable, like easily we can integrate it. So what can be the process? So here I can see cos 2x is there. Here's 2 sin square x is there. So one thing we can think about is, let's convert this 2 sin square x in the form of cos 2x. So there is a formula of cos 2x which can give the result cos 2x is equals to, can we write 1 minus 2 sin square x? Do you know this formula, that cos 2x is equals to 1 minus 2 sin square x? So either we can convert this cos 2x in terms of 2 sin square x, or we can convert this 2 sin square x in terms of cos 2x. Whatever like suits to you, you can take that. Whatever feels comfortable to you, you can take that. So if I am taking at the place of cos 2x 1 minus 2 sin square x plus 2 sin square x. Can you see it? Can you see the formula which I have written over here at the place of cos 2x? This one. Okay. Divided by cos square x. Now you can see this one and this one will cancel out each other and we will be left with 1 over cos square x. That is sec square x. So rather than doing the integration of the whole term, that is cos 2x plus 2 sin square x divided by cos square x, we ended up getting only sec square x. And we have to do the integration of this sec square x dx, which is tan x, right? Plus constant of integration. Is it clear to everyone? Yeah, is that clear? Okay, yes, it's clear. Let me take the other doubt. Yeah, everybody, please write your doubt, or you can also unmute yourself to tell which number or which question you are having doubt. Okay, so I'm taking doubt of each and every one. Once we will be done with the doubt, then we will be moving ahead. So here we are having the next question as, ma'am, can you explain question number 11 and 13 from exercise 7.3? Let me check the question. So question number 11, it's cos to the power 4 twice x. Okay, So here, what can be done? Here we can use the formula. Which formula we can use over here? So we know the formula of cos 2x, which is, can anyone tell me what's the formula of cos 2x in terms of cosine? In terms of cosine, not in terms of sine. Anyone? Yes, anyone? Yeah, let me check. Yeah, the formula is 2 cos square x minus 1, right? It's, if I'm talking about cos 2x, then we will be writing 2 cos square x minus 1, right? Let me take that. 2 cos square x minus 1. But here, okay, let's take it as it is. Here we are talking about cos to the power 4 and then 2x is there, which can be written as cos square 2x, and that's whole square. So basically here we need cos 2x. Here we need, instead of x, here we need 2x. So here also at the place of x, we will be writing 2x. So the formula will become cos 4x is equals to 2 cos square 2x minus 1. Is it clear to everyone how I am writing this formula? At the place of x, we are taking 2x. Okay. If you are not getting from here, you can understand it like this, that at the place of this x, it's not x, it's 2x. Here also, it's not x, it's 2x. Why 2x? Because in our function, the given function, we are having 2x. Getting it? So the formula became cos 4x is equals to 2 cos square 2x minus 1. From here, we will be finding the value of 2 cos square 2x will be cos 4x plus 1, right? And here we will be having cos square 2x is equals to cos 4x plus 1 by 2. Can you see it? Cos square 2x is equals to what? I am going to replace that cos square 2x with this one. That is cos 4x plus 1 by 2. From where it came? It just came from the normal formula, that is cos 2x is equals to 2 cos square x minus 1. At the place of x, there we have taken 2x. Okay. So the left hand side became cos 4x and the right hand side became 2 cos square 2x minus 1. After that, we have done the simplification as per our requirement. So let's substitute it. We will be having cos 4x plus 1 divided by 2, that's whole square. Okay, now let's do the squaring. If we will do the square of the denominator, it will be 1 by 4. And if we will do the square of the numerator, it looks like the formula a plus b whole square. Can you see it? We are having cos 4x plus 1, that's whole square. Let's do the squaring. Let's expand it according to the formula of a plus b whole square. So 1 by 4 a square, that is cos square 4x plus 2ab, 2 into cos 4x into 1 plus b square, that is 1 square. This is the whole expansion we will be having. Yes or no? Let me segregate the parts. Here we have made the formula and there we are solving the question. Okay. Now we will be having 1 by 4. Here cos square 4x plus 2 cos 4x plus 1. Here you can see we can integrate it now only. Can you see? Now only we can integrate it, but still there is a thing which we need to sort it out. This one, easily we can integrate it. 1, easily we can integrate it. But what about this one? For the first term, that is cos square 4x. Still we need to work on that. How we will be doing that? So here, the same formula, replacing x by what we need? We need 4x. We need 4x over here. In the same formula, whatever we have taken it out earlier, I am going to take the same formula again. But now what we need? We need cos square 4x. Here the formula which we have made in the rectangular box, this formula is cos square 2x. So to make it 4x, on the right hand side, I am going to replace x by 2x. Is it okay? Is it okay? Wherever x is there, I'm going to write 2x over there. Okay. So cos 4 x is there, I'm going to write 2x over there. Plus 1 divided by 2 is equals to cos square 2. Wherever x is there, I'm going to write 2x over there. Why I'm doing so? So that we will end up getting cos square 4x formula. We can still start from the very beginning and we can make the formula, but why to go that much far? Still we are having the formula in hand. Just by replacing x by 2x, we will be getting whatever is required, right? So we are going to take cos square 4x, that will be cos 8x plus 1 by 2. Is it clear to everybody? Is it clear? Yeah. Okay. It's clear to everyone. Let's continue. So I'm going to write 1 by 4. Cos square 4x means cos 8x plus 1 by 2 plus 2 cos 4x plus 1. Let's separate each and every term so that we can integrate it easily. So we will be having 1 by 4. Here cos 8x by 2 plus 1 by 2 plus 2 cos 4x plus 1. Here we can do the simplification by taking 1 plus 1 by 2. So we can write it as 1 by 4 cos 8x by 2 and 1 plus 1 by 2. It will be 3 by 2 plus 2 cos 4x. Now let's do the integration part by part. So we will be having 1 by 4 cos 8x by 2 plus 3 by 2. Let's write 1 by 4 outside because that 1 by 4 belongs to each and every term sitting inside the bracket. Okay, dx plus 2 cos 4x dx. This way we can do the integration, part by part integration of each and every term. So we will be having 1 by 4 here in the bracket, 1 by 2 is there, and cos 8x. That's what's the integration of cos x? What will be the integration of cos 8x? Like you are you have gone ahead and you must know what will be the integration of cos 8x. Cos x integration sin x. And what will be the integration of cos 8x? Anybody? Cos 8x integration. You are doing trigonometric function. Yeah. Sin 8x by 8. Exactly. So no need to explain why we are getting sine 8x by 8, because you must know, since you are doing trigonometric functions, a very tricky questions where we are applying the formula, doing a lot of calculations and all. So the basic concept, that is cos 8x, that integration will be sine 8x, and then since it is not x 8x, so we again differentiate it and write it in the denominator, plus 3 by 2 x plus 2 cos 4x over, not cos 4x, sine plus 2 sine 4x over 4, that plus constant of integration. Now you can simplify it further to get the final result. Is it clear to everyone? Is that okay? Let me check. Yeah, is it clear to everyone? Yes, it's clear. Yes. Okay, let's move ahead and do the next question. So the next question was 13 number. Yeah, 13. Let me take that. Let me check what exactly is number 13 question. Okay, so number 13 is cos 2x minus cos 2 alpha divided by cos x minus cos alpha. Again, we will be, at first, we will try to simplify it. Once we will be done with the simplification, once we will see something, whatever integration formula you have memorized, if every term looks like that only, if it is easily integrable, then only we will go ahead and we will integrate them. But before that, we need to do the simplification over here by using the trigonometric identities, formulas, everything. Okay, so here the first term, like without even understanding what exactly we need to do over here, I can see here the first term looks like cos 2 alpha, cos 2x. There is a formula for that. Cos 2 alpha, there is a formula for that. How you will understand which formula exactly you need to apply and what exactly you need to do in a particular question to go ahead. Whatever feels like you, whatever formula you can see is applicable over there, just go and apply. It may work, it might not work. Two things can happen. If it is working, well and good. If it is not working, obviously you have to think about any different approach. Okay, so here I don't know how to do it, but when I'm looking at this cos 2x and cos 2 alpha, I'm feeling like, okay, let's take the formula of cos 2x, take the formula of cos 2 alpha, and let's apply it over here. Let's check whether it's working or not. So let's check whether it's working or not. So cos 2x formula in terms of cos or in terms of sine or in terms of cos and sine. In denominator, only cos is there. So why to go for sine? Okay, let's take cos only. So the formula is 2 cos square x minus 1. And what about cos 2 alpha? The same formula will be there. That is 2 cos square alpha minus 1. Let's write it over there in the numerator. So 2 cos square x minus 1. That is for the first part. And what about the second? The same formula in terms of alpha. So 2 cos square alpha minus 1 divided by cos x minus cos alpha. Now in the numerator, what exactly we'll be having? Now if you are thinking that why to make it square, because integration of doing a square is like not possible, or again we have to do some simplification. When we are having cos 2x, that integration is possible. Yes, the integration of cos 2x and cos 2 alpha is possible and can be done easily. But due to this denominator, we have to do some simplification over here. Okay, so I'm going to write 2 cos square x minus 1 minus 2 cos square alpha, and this minus 1 will be plus 1 divided by cos x minus cos alpha. Now we will be having this 1 and 1 will cancel out each other, and we'll be having 2 cos square x minus 2 cos square alpha divided by cos x minus cos alpha. Now in from the numerator, we can see 2 can be taken out as a common factor. So let's take it out. We will be having cos square x minus cos square alpha divided by cos x minus cos alpha, which will give us 2. And this, does it looks like a square minus b square to you? Everybody, a square minus b square, like a square minus b square, which gives the formula a plus b in one bracket and a minus b in another bracket, right? Let's expand it according to the formula. So I am going to write it as cos x plus cos alpha in one bracket, and then cos x minus cos alpha in another bracket, divided by cos x minus cos alpha. Now you can see something is getting cancelled out from the denominator, right? Let's cancel them out, this and this. So what are we left with? We are left with 2 cos x plus cos alpha. Now we have to do the integration of this one. So 2 will be out, cos x dx plus cos alpha dx only. Okay, please don't take d alpha over there, because obviously we have to integrate all the function, the given function, with respect to x only. Okay, so here we'll be having cos x will be sin x, 2 will be outside, and cos alpha will come out, and we just have to treat it as a constant. Cos alpha is nothing but just a constant. Okay, we have to do the integration for dx over here, that is x, and then constant of integration. Are you getting it, everyone? Is it clear? Yeah, rest of the student, please ask your doubt. Integration of cos alpha, that is just a constant, the constant just like a, b, c, d. If suppose at the place of cos alpha a is there, then how you will treat that? You will keep a out and you will do the integration of dx, that is x. Similarly, cos alpha is nothing but just a constant. Okay, we are going to treat it like a constant, because x, alpha, everything, we cannot integrate everything like with respect to, like one I'm integrating with respect to x, another I'm integrating with respect to alpha. These things we don't do. Okay, when whatever function is given over here in the whole exercise, all the question we just have to integrate in terms of x. Okay, if alpha is there, beta is there, gamma is there, whatever is there, a, b, c, d, anything is there, those are just the constant for us. Okay, is it clear? Cos alpha integration I have not done. Can you see? I have just taken, yeah, I have just taken cos alpha outside. The way we treat 2 dx, how you find? The integration of 2 dx will be 2x. Similarly, the integration of cos alpha dx will be cos alpha out, and integration of dx we will be doing. Okay. Now, anybody, if you want to ask any question from this exercise, the trigonometric function, integration related to trigonometric function, please do ask. Otherwise, we will be moving ahead with the next topic. No one? No query? Okay, let's start. So today we are going to just start the next integration, that is integral of some particular functions. Okay, so here we are having few formulas. Okay, we are going to use this formula while doing the integration of a lot of given question. And from where this formula exactly came, let me write the formula, then I'm going to discuss that from where exactly this formulas came. So we are having the first formula is dx by x square minus a square. That formula is 1 by 2a log x minus a over x plus a plus constant of integration. Whenever you see any function looks like dx by x square minus a square, not exactly, but something like this, then we can directly write the integration and we can directly say it will be 1 by 2a log x minus a by x plus a plus c. How exactly this formula came, I'm just telling for this one. Now the rest of the proof we are not going to do. So here we have done like this: x square minus a square can be written as x plus a in one bracket and x minus a in another bracket, right? Now here we will be doing some arrangement. What type of arrangement we are going to do? Either we can use the method of partial fraction, okay, partial fraction decomposition we can do over here, or we can also do arrangement like x plus a and x minus a, so that x and x get cancelled out with each other. So minus x, this way I can write it, so that when I will open the bracket, x and x will just get cancelled out with each other and a will combine with each other. What I am doing exactly, in numerator we are having 1 over here, 1. So here in numerator I am trying to do some arrangement, but I'm not able to make 1 on the right hand side. I ended up getting 2 over here in the numerator. So I will divide it by 2a so that 1 must be there in the numerator. Now in the denominator, I'll be writing whatever is there. That is x plus a, x minus a. Now what we can do, let me rub this part. Yeah. Now what we can do, we can separate the terms. So we can write it 1 by 2a, just keep it aside, and we are having integration of the first term x plus a divided by the total denominator, that means x plus a, x minus a dx, and then the second term x minus a by total denominator x plus a, x minus a. You must not get confused why I am writing like that, because in mathematics you must have done the fractional addition and subtraction, and there you know that when we are having 2 by 3 plus 5 by 3, we write it as a 2 plus 5 by 3. So why not, when we are having 2 plus 5 by 3, we can write it as a 2 by 3 plus 5 by 3. So same thing I am doing. We are having something minus something by a denominator. Denominator x plus a, x minus a is a single thing for us because both are in multiplication. So I am taking first numerator with all the denominator. I am taking the second numerator with all the denominator. Okay. Now from here you can see the terms are cancelling out each other. So which terms are cancelling out? This x plus a got cancelled out. This x minus a cancelled out. So we will be left with dx by x minus a over here and minus dx by x plus a, which looks like the formula of log x. That is 1 by x and times dx, right? That's the formula of log x. So it looks like log x, and from here only the original formula which I have given number 1, that came. Okay, so in each and every case we are not going to discuss from where exactly the formula came. Okay, we will be doing the problem directly. I am going to write all the formulas and directly we will start doing the problems. Is it okay? Okay, let's start. So this next formula is, you should memorize this formula. Okay, just after the class, just go ahead and memorize this formula, the first one. That is, the integration of dx by x square minus a square is 1 by 2a log x minus a by log x plus a. Log x minus a by x plus a. Log and log just came together, and here we are having written in terms of division, because you can see in our deduction there is a minus sign. So minus log m minus log n will be log m by n, right? Same formula applied over here. Number 2, we are having the formula dx by a square minus x square. That will be 1 by 2a log a plus x by a minus x plus constant of integration, obviously. Number 3, if we are having dx over x square plus a square, that's formula is 1 by a tan inverse x by a plus constant of integration. Now, number 4, don't worry, when we will start solving the question, we will get back to this formula and I'll be telling you how to use this formula. Okay, when we are having dx by under root x square minus a square, that gives the formula log mod x plus under root x square minus a square plus c. Number 5, when we are having dx over under root a square minus x square, this formula, few of them came from the arrangement which I have shown to you. Few of them came from the trigonometric substitution. So this is the formula for sine inverse x by a plus c. Now the next one is number 6, that is dx by under root x square plus a square. That will give us log x plus under root x square plus a square plus c. So these are the 6 formulas which we are going to apply while doing the integration. The formula which you have learned, what is the integration of sine x, what is the integration of cos x, what is the integration of sec square x, what's the integration of 1 by x dx, what's the integration of e to the power x. Similarly, these are few more formula which you have to memorize, which is just the inclusion with that, like whatever formula we are having, this got included over there. Okay, now let's see few problems related to these formulas. So the first question, the first question I want to take as the integration of, we have to find the integration of dx by x square minus 16. Now we will go back and we will see it looks like which formula. X square minus 16 is there. Okay. So can you see the first formula? It looks like x square minus a square because we can write 16 as a square of 4, right? So we can represent this one as dx by x square minus 4 square. Now rather than doing the whole thing which we did for part 1, that is doing the arrangement or going and doing the partial fraction decomposition, whatever, rather than doing that whole thing, we can directly use the formula which says, let's get back to the formula. It looks like x square minus a square. And what the formula of x square minus a square says? The first formula, can you see? Dx by x square minus a square, whenever we are having, the whole integration will be 1 by 2a log x minus a by x plus a in mod plus c. Okay, let's write it. So the formula was, whenever we are having dx by x square minus a square, the formula was 1 by 2a log of modulus x minus a over x plus a plus c. Which formula I have taken? I have taken the first formula. Okay. Let's apply the formula. So the formula says at first we are supposed to take 1 by 2a. So 1 by 2. What is our a? A is 4. Okay. Log x minus a, x minus 4 divided by x plus a, x plus 4 plus C. And we are done. This is our answer. 2 into 4, you can write it directly as a 8. I have just shown you by breaking the step. So this is our answer for the given integration. Rather than doing a lot of arrangements and all, we just ended up doing it in one step. Is it clear to everyone how we are using the formula? Yes, it's clear. Okay, let's take few more problems. So if we are having the question as integration of dx over under root 2x minus x square. Now we will check it out which formula, like it looks like which formula, or we can make it like which formula. Okay, so when you will see 2x x square, are you getting that we can make it perfect square, the under root term? Because in all the formula you can see a square this there, x square is there, x square a square. Here also every formula is having x square a square, either inside the root or without the root. So here we will try making it like the formula. How can we make it? Here we don't have a square, right? We don't either have x square because 2x terms is 2x term extra is there. So let's make it perfect square. Okay, how to make it perfect square? So we can take it out minus common, and we can write it as x square plus 2x for now. Okay, after that what can be done? Dx by under root, minus is out, a square minus 2 plus is there, 2 into a into b. At the place of b, what is there? 1 is there. So we are supposed to add 1 square and then subtract 1 square. Is it clear to everyone what exactly I am doing? We will be having dx over minus, and then inside the bracket it became x plus 1 whole square minus 1 square. Okay, now inside the roots minus is there, so let's take it with curly bracket. So when we will be taking it with the curly bracket, why I have taken out minus common? So that you can visualize the formula, a square minus 2ab plus b square, or a square plus 2ab plus b square. We are making it perfect square formula. Okay, divided by, I am going to write it as 1 square minus x plus 1 whole square. Now let's check it looks like which formula, where under root a square minus x square is there in the denominator. Do we have any formula like that where we are having a square root also, and inside the square root in the denominator a square minus x square like terms are there? Do we have any formula? Let's check it out. Do we? Can you see number 5th formula? Under root a square minus x square. That formula is sine inverse x by a. So let's write it. This one's formula is sine inverse x. What is our x? Our x is x plus 1 by a. A is 1. Whenever our x is different, what we do, we again differentiate it by keeping it in the denominator. But when we will differentiate this x plus 1, we know nothing will come, 1 will only come. So I am going to leave it plus constant of integration. Is it clear to everyone? Let me check. Oh yeah, it should be minus 2x. I have taken it this as a plus 2x. So when we are taking out minus common, it should be minus 2x. Here it should be minus 2x, and now since we are having minus 2x, the formula will become a minus b whole square. Okay, instead of this one we will be having a minus b whole square, and now here we will be having x minus 1 by 1 plus c. What was the question? The question was, yeah, is it okay now? Here we have taken minus common. It became x square minus 2x, x square minus 2 times a times b plus a square minus b square. I have taken all by myself. Then it became the formula of a minus b whole square and minus 1 square. Yeah. Is it clear now? Is it okay now? Instead of x plus 1 whole square, we are having x minus 1 whole square according to the given question, where we were having dx by under root 2x minus x square. Yes, is it okay now? Shahid? Yeah. So this is how we will use the formula. Okay. Now the next question is, please try this type of question from the exercise. All the question which just belongs to like which just by applying the formula which can be taken out the integral, please do that question by yourself from the exercise. Now the next question we can take it out as a dx by x square minus 6x plus 13. Okay, here also we will be trying to use the formula. Which formula? The above formula. But how you will identify which formula you are supposed to apply during the exam when all the integral will be mixed up? That time you will just be so prepared by doing a lot of questions and all. Just by looking at the question you will be able to identify, can we do this one, and you have to try that approach. Okay, here the specific questions are there in specific exercises, and you know that there you have to apply the trigonometric rule. Here you have to apply the special, some particular formulas are there which you are supposed to apply. But when everything will be mixed up, please don't get confused. Practice enough so that just by looking at the integration you will be able to identify which formula can be applied over here. Okay, so here we can think about again making it as a perfect square. Okay, so what can be done over here? Let's think about it. Let me check. Yeah, so we can make it perfect square again just like the previous method. So dx over x square is there, write it as it is, minus 6x is there, and the formula of a plus b whole square and a minus b whole square, both the formula contain 2 into a into b. So the best way to break this down 6 as a, just write 2 into a. Now we want to make 6x. What we have in hand? 2x. What extra is needed? 3. If you are doing like that, then you are just it will be very simple to break it down. Now what is your b? 3. So now b square is also required. Now all of sudden we cannot add plus 3 square. Okay, we have to maintain the balance, so we have to subtract 3 square also. Plus 13 I am going to write as it is. Okay, now dx over this became a minus b whole square. This total term I have taken together. And this minus 9, this minus 9 plus 13 will get absorbed with each other. So 9, 10, 11, 12, 13, 4. Positive 4 we are having over here. We ended up getting dx by x minus 3 whole square plus 2 square. We will get back to the formula list and we'll check is there any formula which will be applicable over here? So we are having a pattern like x square plus a square, like this one, number 3. So directly we can go and we can write the formula, that is 1 by a tan inverse x by a. So let's write it. This will give 1 by a, what's a? Tan inverse x by a plus c. Okay. Now, instead of x, we are having x minus 3, but no need to worry about that because the coefficient of x over here is 1. And after that, a constant term is there. So even if you will do the integration, the differentiation of x minus 3, and you want to keep it in the